Hello everybody, this is Nick. In our last video we talked about A to Ds and why you might use an A to D. Now let's actually kind of program an A to D. And because in this lab we play a lot with picks, let's look at one of these picks. Now this is the data sheet for the pick 18F XX well, 452 pick, but it's a whole family of picks. And this is a fairly generic pick. So no matter which processor you use, the process will be similar. For you guys that are messing with Arduinos, this is Arduinos makes it very simple, but this is how most of the world will live. So the first thing you need to do is you need to open up the data sheet. And you need to internalize in your head how it's wired internal to the chip. So let's take a quick tour of what the chip is. On this side we see there's 8 inputs, all right? And these inputs are switched or muxed so that the first thing you need to do is configure one of these switches. We typically start with channel 0, but that's up to you. So the first thing you do is you're going to use some registers or some libraries to set this switch. One of the next things you need to do is you need to set the reference. Remember that an A to D is basically a 3-port device. Is that some voltage you want to measure comes in, you have some reference, and the output is a function of the voltage in over the reference. So there's some other things we need to configure, and in the data sheet it just explains in detail what the registers are. But remember, all authors of data sheets stay at night trying to confuse you. So if you're like me, you have to read the data sheet several times to decipher what these authors are trying to tell you. Also, if you're lazy like me, you can use the libraries to help you configure it, and it tends to be a little easier and makes the code read a little better. So the next document you need to go to is you go to the compiler, and since we're using the C18 today, here's the C18. Well, where is it? Here's the C18 compiler. Of course, these documents are many pages long. Use the index. Alright, so here are the 6 commands associated with the A to D on the PIC. They're listed in alphabetical order, but I'm going to talk to them in the order which you operate them. So the first, well, let me diverse and say that the A to D functions use multiple. Let me go back over here. These ports over here are multi-purpose ports. They can either be A to D ports or they can be general input-output. So the first thing you need to do is you need to define these guys as inputs. So if you're going to wire an input voltage to AN0, you need to go through the definitions of defining that port and making an input. All right, back to the A to D operation. The first thing you need to do is configure the A to D, and we do that in the open statement. That's where we tell it which channel it's on, we tell it some other information. Once you get the A to D open, you're going to want to start the conversion, and the command is convert ADC, which starts the process. Now it turns out it takes several clock cycles for A to D complete, so you don't want to read it before it's through. So you're going to test to see if it's busy. All right, and we'll go through this. And then once you start the process, it gets completed. Then at that point you'll read the ADC. If you want to change the channel, you'll use this set channel command. And then when you're through, you're going to want to close the A to D. All right, so let's go through, just a thumb down here and in order. Okay, the first function we talk about is busy. All right, and we will embed that in a while loop. So this is, we will test to see if this guy is busy by using this command, this function. The next function we see is close, and that's just simple. I'm done with ADC. Close it, and that I think is self-explanatory. The next thing we're going to do is the next command we're going to talk about is convert, and this actually starts the process. So when you actually want to actually start the A to D conversion, you will use this function, right? Now here's the open. Here's where we actually do the configuration. Before you do an A to D, you got to configure it, and that's done with the open function. And notice that it's open ADC and a bunch of characters, unsigned characters that are ANDed, right? So the first thing you got to do is looking for the clock source. All right, in this lab, most of us choose this one right here. Oops. Well, I'm having a tough time here. We choose, well, all right, we choose this one. All right, we choose this thing, and we say that we're going to take the oscillator and divide it by 32, and that seems to work when we use a 10 meg deal. So my recommendation is start with this one. You need to go faster, you can increase it. Because this thing, this PIC is a 10-bit A to D, you need to talk about how you want to justify the deal. We pick right justify. You can do whatever you want. All right, so now we need to configure the reference voltage. All right, you have all kinds of choices. If you go with an external reference, you'll choose one of these. If you go essentially with the internal reference, where the reference is the VCC, so if we're working with 5 volts, the VREF will be 5. You will choose this setting here when it's ADC underscore 8 ANA underscore OREF. So you need to put that in the configuration, and we'll go through some sample code here in a minute. All right, now we're going to skip down and go down to an example sample code. If I can get there, let's see. Come on, come on. My recommendation is that you read all of these things and understand them. Go through several of the examples and internalize the examples. And this software doesn't let me skip around a lot. Oops, I overstepped it. Let's see if I can back up here and find it. It's in the I2C. I'm having a tough time finding it. Let's see. Yeah, this will do it for us. So this is some sample code. So the first thing you do is you notice there's an open statement. All right, and here are all the switches that you set in the open statement. This saying the clock is divided by 32. We're going to write justify. This tells us we're using the 5 volt VCC. This over here tells us which channel we're on. We're on channel 0. And this switch tells us that we're not using interrupts. And my recommendation is when you first get started is don't use the interrupts, but you're going to want to learn how to use interrupts as you go along. So the first thing you do is you open the ADC, give it a little delay. It takes some time for the processor to go, the library to go do all this. Their recommendation is 50 clock cycles. All right. The next thing is you're going to start the conversion. All right, and then you're going to test. In other words, once it starts, you don't want to go try to read it. So you're going to want to test through with a while busy. This is a good example. When this thing gets through reading, it'll break out of this while loop, and then you're going to read it. And I didn't go through the read command. I'm going to try to back up and see if I can find the read command for us. It turns out that this thing returns an int, so result is an int. And then when you get through, you close it. So let's go back and look, see if I can find the read. Let's see, this is busy, close, convert, open, 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 read. Here is read. This function reads the 18-bit results of an A to D. Well, okay, they didn't tell us a lot about what it returns, but when you do a read, it returns an int. And remember, when you're doing math on int, you got to do some typecasting. And if you print it, if you print an int, you either got to do an I to A or a printf function. So guys, that's it for A to Ds. I encourage you to go ahead and wire one up and play with it and ask for questions. So long for now.